Good afternoon. Welcome to our final presentations for our 2021 class of STEP students. For our guests and our audience members, I would appreciate it if in the chat you would just quickly introduce yourself and what organization you're with so that our students know who the audience is for their presentations today. So what we're going to do is I'm going to talk for just a couple of minutes to sort of set the stage and explain the background of the program. We have a number of partners and sponsors who have been part of this program, so we'll give each of them a chance to speak, with the exception of our speaker from Lockheed, who will come on at the end. He's on a flight right now. I will explain the challenge problem that was given to the students, but the majority of our time today is going to be dedicated to letting the students tell you what they did. We have 21 students, each of whom is going to tell you the story of their journey through the past 3 weeks as they've worked to build and modify their Mars rovers. So we'll talk about that as we go through. And then I'll just have a few closing remarks at the end and we'll be done. And the plan is to be done no later than 3 o'clock today. So the STEP program, I want to say it's year 6 of the STEP program. It's something that was started with the idea of having Georgia Tech reach back into the community and help build that pipeline of our future engineers starting in high school. We've been fortunate to have Lockheed support the program every year so that we've always been able to do it at no charge to the students. So it really is a program that's meant to be open and accessible to everyone, to give everyone a chance to enjoy and learn an engineering experience. What we found over the years is that the students who participate in STEP walk away feeling confident, feeling like they know what they're doing, really feeling like engineers, and it's something that every student can use to improve their college application process. So I think the impact, and I think as you hear from our students today, you'll hear that the impact on the students is quite great. So we've been very pleased to be able to continue offering this program every single year. Now, as I said, it's not a new program, but the past 2 years have been challenging, to say the least. In 2020, we found out we weren't going to be able to have the program on campus like we usually do about a month before it started. So we had to do a pivot, and we ended up designing the Mars rover kit that you're going to see the students present about today. The challenge has been to build the kit and then design and implement an improvement. So last year, with this being the first time we tried it and such little planning time, we actually only had 9 students in the program. So this year, the big challenge was we made some improvements to the kit, but the big challenge was to scale the program to allow a larger number of students to participate. And I think you'll see that we were successful in getting a bigger group this year and being able to have everyone still engaged meaningfully in the project. But what I loved the most about the virtual setup is that it's enabled students who may not have otherwise been able to do this program to participate, because it doesn't require transportation to Georgia Tech, meaning that if you live a little further away from campus, you can be part of the virtual program. So one of the things that I've really loved this year is that we've got students from all around the state, not just from the metro Atlanta area where we usually do. So while there's plenty of challenges to doing this virtually, and you'll hear about some of those as our students present, there's also the plus side that we've been able to reach out and include a larger group of students from around the state. At this point, really, this program has been made possible through a collaboration of 4 organizations. The Georgia Space Grant Consortium and the Aerospace Systems Design Lab have partnered for a long time to make this program possible. And that's where our mentors for the program, the administration, and sort of all the background support for the program is done by folks in those 2 organizations. In addition, Lockheed Martin has supported us every year since the beginning generously and has been our primary sponsor of this program, so we're very grateful to them. And this year we had additional support from the Safe and Secured Autonomy NASA ULI. And so I was going to give each of our partners a chance, just a moment, to speak about why their organization chooses to be involved in this program and sort of what they feel about it. So Dr. Ruffin, do you want to start for Georgia Space Grant?
Sure, I'd be happy to do that. Welcome, everyone. My name is Steve Ruffin. I'm a professor and also associate chair for the Aerospace Engineering program at Georgia Tech. And I'm also director of the Georgia Space Grant Consortium, which is one of the sponsors for this event. I just want to say I'm really excited about each of you participating in this program and what you've been able to do as part of this. This is a great opportunity, and one of the things that we do here in aerospace engineering at Georgia Tech. Wanted to tell you a little bit about AE at Georgia Tech. You are being engaged by a program that's part of the best aerospace engineering program in the country. Actually, U.S. News and World Reports ranks all of the aerospace engineering programs. They have MIT ranked #1 and Georgia Tech ranked #2, but we're really better than they are anyway. But this is what aerospace engineering is, and it happens to be right here in Georgia. If you're interested in going to aerospace, then this is a great program for you to engage in. Our students in the program learn not just about things related to Mars rovers, but anything that flies. So you learn the science and engineering associated with aircraft, fixed wing aircraft, either for commercial or military applications. Unmanned aerial vehicles or drones, you learn about that. You learn also about spacecraft, either launch vehicles or reentry vehicles, as well as systems that operate in space, such as rovers. So this is a great program in which to learn all of those things and really to apply it. It's a great program for a variety of reasons, but one of the reasons I will say is that in addition to the great coursework, 84% of our students, when they graduate, have done some sort of great engineering or science outside the classroom. And this can be design projects that students do. You've done a design project here as part of STEP. So our students have an opportunity to do a variety of those types of projects. Some work at NASA centers or other industry partners during the summers, either as part of an internship program or co-op program. One of the programs that aerospace engineering is involved with is the Georgia Space Grant Consortium, which helps sponsor and help fund this event. Georgia Space Grant Consortium is funded primarily by NASA, and we're here in Georgia. We're all across Georgia, really, and it's not just Georgia Tech, but we're a collection of 21 organizations around the state of Georgia that participate every year. And then we have several other organizations that participate. And what we do is we help support design projects that undergraduate students will be doing. We help support internships, so helping to fund students that are going to NASA centers. We help support graduate students working on masters and PhDs in their graduate programs. And we sponsor lots and lots of programs such as STEP for the K through 12 area. Overall, you've been working with Dr. Grinling and several others, and I hope you see that this is a collection of folks that knows what they're talking about and are really excited about this program. We're really excited that you've gotten a chance to do some aerospace work. I mean, this sets you above many other students who haven't had this opportunity, and I've been hearing great things from Dr. Grinling about how this has been going. She's really impressed at what you've been doing, and all of us online are happy to be learning more about that. So keep up the great work. Do great in school. Keep doing programs like this, and love to hear more about your individual accomplishments. Take care.
Meg, do you want to jump in and maybe say a few words on behalf of ASDL, since something seems to be wrong with Dr. Mavris' audio?
Yeah, certainly. I'll do my best. So on behalf of Dr. Mavris and ASDL, I wanted to say that we're really proud and happy to be a continuing partner for STEP over the years. I think our role has evolved over time, and what we do now is provide mentors in some of our research faculty. And I know they all enjoy working with the teams on their challenges, and they're enjoying their accomplishments as well. So anyway, congratulations to you all, and we're happy to support.
Dr. Van Voudakis, do you want to talk for a few moments on behalf of the NASA ULI?
Thank you very much, Kelly. So yes, I will be happy to talk about it. So I would like to welcome everybody. This is Kyriakos Van Voudakis. I'm an assistant professor at Georgia Tech, and we will be happy to also host your studies, not only your these kind of studies. And so I'm part of NASA ULI grant, which is in collaboration with North Carolina Agricultural and Technical State University, at Purdue University, Alakai Technologies, Aurora, General Atomics, and Northrop Grumman. And in 2 words, we make flying taxis. So we make flying taxis that they can fly by themselves. They're secure to any attacks that can happen. And so if you want to be involved in such projects, we will be happy, and I will be happy actually to have you in my lab. And so yeah, so again, welcome, and thank you for everything, and I'm excited to see the presentation.
And I've got a much longer list of thank yous at the end of the presentation, but I did want to take a minute and call out to groups in particular that helped us a lot with recruiting. So all of you found out about this program primarily through your schools. And so one of our challenges is how to get the information out to your schools. And so the Center of Innovation for Aerospace and the Georgia Tech Community Relations Office were instrumental in helping us get the word out this year. And as a result, we have the highest number of high schools participating that we've ever had, and the highest variety as far as the number of districts that we have participating. So I wanted to thank you both for all of your help in getting the word out about the program so that we could have this fantastic group of students that we have here today. All right, so let's talk about what the students were challenged to do. So we sent them a kit with a basic Mars rover parts. So they got a box with some electronic components and a bunch of PVC and some screws and some glue and a few robot wheels and motors in the mail at the beginning of camp that probably looked like a giant mystery box. And we spent the first week of camp using those parts to build a baseline Mars rover. And through that, teach a little bit about the engineering process and about how we deal with electronics and how robots work and all that kind of thing. But the real challenge for the students was the scenario that we gave them. So we said, imagine that you're going to be spending a couple of years on a Mars base. And so imagine a mission that you either might do ahead of that, send a rover ahead of time to scout, or that you might do while you're living on the Mars base. You've got the basic parts to build the rover, but you need to design a modification to support your mission. So the rover that we gave them, all it could do was drive. It couldn't take video or do anything else that you might want to do on Mars. And their challenge was to imagine what they might need, figure out what their requirements were, pick out the parts they needed for their modification, implement it on their rover, troubleshoot any issues, and do all of this in time to have beautiful pictures and videos and presentations to show you today. The program was only 3 weeks, so this has been a very fast turnaround of really doing a complete engineering design cycle. On top of that, we gave them a budget. So they only had $50 to spend for parts, which, as you may know, goes very fast on Amazon. They had a $50 budget. And when all was said and done and we dealt with all the shipping delays, Amazon Prime Week fell on the day, or Amazon Prime Day fell on the day we were ordering the parts. So we had nice, good shipping delays to make our program more exciting. They really had a little less than a week to actually make their modifications and troubleshoot them. So I hope that you'll see that they were very successful, and what they did was extremely impressive in a very short amount of time.